All right, so this video lesson is going to be an introduction on how to interpret vapor pressure curves. We've started out with looking at phase diagrams that looked at pressure and temperature and how they impact what state of matter it's going to be. We then looked at heating curves and cooling curves, at how heat can change the temperature of the material to ultimately lead to a phase change, and we can figure out when something's going to melt, boil, condense, or go through freezing. So we have one last graph that we're going to look at, and those are called vapor pressure curves. These curves are useful for looking at liquids and at what temperature are they going to boil based on pressure. So like I just said, there's two variables to the graph, our x and y. We care about the x and y in phase diagrams. Typically in heating curves, we only really care about the y-axis, the temperature part of it. But back to vapor pressure curves, we have vapor pressure. Pressure, again, is looking at a unit like atmospheres, millimeters of mercury, and then we have temperature. So we're ultimately, again, looking at how does pressure impact the temperature at which a material can boil, and more specifically at what temperature can a liquid boil to go through a phase change to go to a gas. Not every material boils at the same temperature. We interact a lot with water. Water at standard pressure, 1 atm of pressure, boils at 100 degrees Celsius. The boiling point of water can change if the pressure changes, and then if you change the identity of the material, when it boils changes as well. So boiling point is defined as the temperature where the vapor pressure of what's the pressure inside the liquid is equal to external pressure. So when you put a pot of water on the stove and it starts to boil, that's because the pressure of the water in the pan equals the external pressure around it. So that's why when you go into higher elevations, boiling point changes. Water will boil at a lower temperature because there's less atmospheric pressure at those higher elevations. So again, various liquids boil at different temperatures, so these are useful at determining when will a liquid boil. So boiling is just a form of vaporization, a liquid changing to a gas. The other type of vaporization is evaporation. That happens at room temperature. So this is where we are adding heat. So normal boiling point, we talked about normal way back with phase diagrams. So normal just means standard pressure. There are three options right now for standard pressure. They all measure the same thing. It's just a different unit of measurement. So anytime it asks what is the normal boiling point, that's at 1 atm of pressure, or atmospheres, 101.3 kPa, kilopascals, or 760 millimeters of mercury. So again, when we rattle off that number, 100 degrees Celsius or 212 degrees Fahrenheit, we are rattling off the normal boiling point of water. That's when it's at these standard pressures. So again, water can boil at a different temperature depending on what pressure it's being exposed to. We are going to, again, talk about intermolecular forces next week, but we've seen this with yesterday's topic as well. Intermolecular forces are forces interacting between molecules, so between the individual water molecules. Again, intramolecular forces are bonds, so the bonds that hold the hydrogen and oxygen together to actually make the water. So the stronger those intermolecular forces are, the higher that material boils. And water is kind of unique. It boils at a very high temperature because it has very strong intermolecular forces. Other material can boil at lower temperatures because it has a lower strength of intermolecular forces. And again, the last factor that decides when a material will boil is the external pressure. So when you go to a higher altitude, like what you find in the mountains, you have lower atmospheric pressure. Because again, the atmosphere is basically exerting a weight down on us. So the higher you go up in elevation, you have less atmosphere pushing down on you. So you have less pressure, and so that lowers the pressure needed for something to boil. So again, in places like Denver, they have water that boils at a lower temperature than what we see here because we're pretty close to sea level. So again, as we go down in elevation, it takes more heat, or at a higher temperature we see boiling because we have more atmospheric pressure pushing down on us than again what we see in higher elevations. So this is what a vapor pressure diagram looks like. Typically you see multiple liquids on it. We can go ahead and take a look at the setup. We see temperature is on the x-axis here. Vapor pressure is on the y. Notice that this particular graph is measuring pressure in kilopascals. So units are really important when we start looking at these graphs. The first thing is you want to identify what's your standard pressure. So again, we have standard pressure. So if you look at your notes above, there's 3 options. Because this particular graph is measuring in kilopascals, our standard pressure is 101.3 kPa. So if you notice, this graph already kind of subtly pointed that out by putting this line in here around the 101.3 kPa. So this is where we find normal pressure for those STP conditions, so standard pressure conditions. Okay. So again, looking at the graph, we have 3 that we're going to really look at. The ethanoic acid line didn't show up, so we're just going to talk about chloroform, ethanol, and water. And can we interpret and answer the question based on what it asks? So the first one, letter A, asks what is the vapor pressure of chloroform at 50 degrees Celsius? So we know we need to identify what liquid it's talking about. So we're talking about chloroform, which is the line or slope all the way to the left. And it wants to know what's the pressure based at 50 degrees. So pressure is on my y-axis. So this is extrapolation, where we can estimate approximately what pressure that will be. So I can see I'm going up by 20. So 50 should be somewhere in between 40 and 60. So I'm going to go up to where it intersects with the line of chloroform. I'm going to extrapolate over. And this is where we need to estimate. Again, this axis is always also going up by 20s as well. Based on what I'm kind of seeing, it's not quite, it looks like it's a little bit above 75, so I'm going to approximate somewhere around 78. My unit is very important here because I'm measuring pressure. That's in kPa. So somewhere in the ballpark of 78, so I would take anywhere from 75 to 79 kilopascals here, because it's definitely not at the 80 line and it's definitely 75 or above. Okay, I'm going to clear those markings off so we can then use this to answer our next question. B asks what's the boiling point of water? So that means I'm looking for a temperature for water when the pressure is 30. So I'm kind of just going in reverse. So the previous problem wanted pressure, this one's wanting a temperature. When is it going to boil? So if I look at 30, so again, that's approximately halfway between 20 and 40. I'm talking about water, so I'm going to extrapolate my line over to where it intersects with water. I need to know the temperature, so I'm going to drop my line down to the y-axis to not to the y-axis, but temperature is on the x. I can see it's maybe not quite 70, so I'm going to again approximate somewhere around 68 degrees Celsius. So again, if you're in the ballpark of having a number similar to mine, you are doing just fine. Just like on our phase diagrams, this next problem has some similar questions that we've seen. It asks, what is the normal boiling point of ethanol? So as soon as I see normal, that means that standard pressure. We already identified standard pressure is at 101.3 kPa. I'm looking at what is it for ethanol. So following my line that they already put in for me at 101, I'm going to find where that intersects with ethanol. So where 101.3 kPa intersects with ethanol, that's where I'm going to trace my line down to approximate my temperature. So it looks like it's not quite flush with the line on 80, so it's not quite 80 degrees Celsius. It's very close to 80, so I'm going to approximate this as 79. It's a temperature, so degrees Celsius. So again, that word normal means that I'm looking at standard pressure. I would recommend at this time to pause the video and see if you can answer the 3 remaining questions. To pick up, letter D asks, what is the boiling point of ethanol? So this is essentially the same question as letter B. All we've done is change the material and the pressure that it's at. So this is at 80 kPa. So boiling point, again, means what temperature is this going to boil at. So we go over from the 80 line to where it intersects with ethanol. And then you should drop down to get your reading. So it looks like maybe somewhere around 76 degrees Celsius should be what you get for an answer. Again, if you're in the ballpark, you're just fine. Next question is asking for normal boiling point. So again, when you see that word normal, it doesn't tell you what pressure. It assumes that you understand that standard pressure for kPa is that 101.3. So you just follow that 101.3 kPa line over to chloroform and drop down. And it looks like, let's see here, let me undo that line. Get rid of this. Okay, so going back to chloroform, it looks like it lines up right with 60 degrees Celsius. So estimating about 60 degrees Celsius is normal boiling point because that was at standard pressure. The last one is like the first question we answered, A. What is vapor pressure of water at 60 degrees Celsius? So we're just going in reverse. So we're going to figure out pressure based on a temperature, and we're looking at water. So I'm going to find my 60 degrees Celsius, go up, I'm going to estimate over. So again, you can draw these lines in if you want, but you don't have to. That's not a very straight line, but it'll work. So it looks like it's maybe somewhere around 22 kPa for pressure. So these are vapor pressure diagrams.